So a percent yield problem is always going to have the words percent yield in it. It makes it a little bit easier to identify. A percent yield problem, we're going to do the exact same 3 steps we were practicing in the last page, going from mass of one thing to mass of another, and then we're going to do one more easy step. The first thing we have to do in a percent yield problem is we're given 2 different numbers. We have 4.65 grams of copper and 1.87 grams of aluminum. One of those is our given. It's how much we start our reaction with. The other one is our actual yield, how much we actually made in a lab. So one thing easy to remember is your given is always going to be a reactant. You start with it. Your actual yield is always going to be a product. So if you read this, it says the reaction produces. Another word for produces is yield. So this is our actual yield because copper is one of our products and aluminum is one of our reactants, so that's our given. Let's make sure the equation is balanced. We have 2 aluminum and 2 aluminum. We have 3 copper and 3 copper. We have 3 sulfate and 3 sulfate. So we're balanced. Let's write our 3 conversion factors. We're always going to go from grams of the given, grams of aluminum, to grams of the actual yield. Because we want to compare what we really made to what we should have made. So if we want to compare the numbers, they both have to be grams of copper. So we're going to use 1 mole of aluminum equals the molar mass of aluminum. And if we look at a periodic table, it's 26.98. We're also going to need to do the same thing with copper. 1 mole of copper equals 63.54 grams of copper. And we're also going to need to use the mole ratio that relates these two. For every 2 moles of aluminum that react, we make 3 moles of copper. So now it's just the dimensional analysis. So remember, we start with our given, that's where we start. So 1.87 grams of aluminum. We want to know how much copper should we have made. So to cancel out grams of aluminum, we put the molar mass on the bottom. That equals 1 mole. So 1.87 divided by the molar mass. So we started with 0.069311 moles of aluminum. Now we need to convert moles of aluminum to moles of copper. So we have, and again I'm rounding here, but I'm leaving all the numbers in my calculator. And to convert between compounds, we have to use mole ratio. So if I want to cancel out moles of aluminum, I have to put 2 moles of aluminum on the bottom. And I want to get 2 moles of copper, so 3 moles of copper on top. Moles cancel out. We have to do times 3 and then divide it by 2. And you have 0.103966. So you should have made this many moles of copper. And now we can go to grams using molar mass. We have moles of copper here. So we're going to put 1 mole on the bottom. And we're going to put the molar mass on top. Multiply. You get 6.60599. Let's talk about significant figures. 3, 4, 4. So we're going to say 6.61. So we should have made 6.61 grams of copper. So this is what we call our theoretical yield. It's what we should have made. So the last new step we have to do, we do actual yield divided by theoretical yield times 100% in order to put it in a percentage. So we do actual. This is the only time we use that number out of the original. Divided by theoretical, and I suggest keeping the whole units on there, that way you know for sure you're doing it right, because if it's not grams of copper divided by grams of copper, something's wrong. So 4.65 divided by 6.61, and then times 100 to put it in a percent, you have 70.348, and our numbers both have three significant figures, so we have 70.3%. So this reaction made 70.3% of what it should have. Doesn't seem like a lot, but that's actually a pretty decent yield for a real life reaction. So here's another example. You can see again it has the words percent yield. We have 84.8 grams of Fe2O3. That is a reactant, and it even says it reacts. So this is our given, with an excess of carbon monoxide, and 54.3 grams of iron is produced. So that must be our actual yield. Let's make sure our equation is balanced. We have 2 iron and 2 iron. We have 3 plus 3, that's 9. We have 3 plus 3, that's 6 oxygen, and 6 oxygen. We have 3 carbon and 3 carbon. So this equation is balanced. Let's write our conversion factors we'll need. We'll need to get the grams of Fe2O3 into moles. So we'll need to know that 1 mole of Fe2O3 equals the molar mass. So 2 irons, and iron is 55.85, and oxygen is 16. So the molar mass is 159.70 grams of Fe2O3. We'll also need the molar mass of iron. So 1 mole of iron, and we just said iron was 55.85. Equal to 55.85 grams of iron. And the last one we'll need is the mole ratio to get from Fe2O3 to iron. So for every 1 mole of Fe2O3 that reacts, 2 moles of iron are formed. And let's do our dimensional analysis. Remember, we start with our given, so we have 84.8 grams of Fe2O3. In order to cancel out grams of Fe2O3, we have to put its molar mass on the bottom. So 159.70 grams is equal to 1 mole. So grams of Fe2O3 cancel out, and we get 0.530996 Now we have to use mole ratio to convert from moles of Fe2O3 to moles of iron. And we got these numbers for our mole ratio from our balanced equation. So we know it is 1 mole of Fe2O3 and 2 moles of iron. And you should have 1.06199. And the last step use molar mass to get grams. So moles are here. That means mole has to be here. And the molar mass has to be on top. So you get 59.3122. And if we look at our significant figures, we have 3, 5, 4. So if we round that to have 3, we get 59.3 grams of iron is our theoretical yield. So we do actual over theoretical. And sometimes you might feel like you're going to forget which one goes on top. And I will say in most cases it's going to be the smaller one. The only way you can make more than what you thought you made is if your product is impure. That means it has extra stuff in it. So maybe it was wet and you didn't dry it out enough, so you have some water there too. But in most cases you'll have a theoretical or a percent yield less than 100. So your actual yield will be smaller, and so the smaller number goes on top. So 54.3, and make sure in this case you don't keep that whole 59.3122 in. We've done significant figures. Go ahead and round it to significant figures. Times 100. You have 91.5683. So for 3 significant figures, you have 91.6% yield.